7-6, number 1, it says sine theta equals 8/9. 0 is less than theta is less than pi over 2. Well, 0 is less than theta is less than pi over 2. We're in this quadrant where everything is positive. So we don't have to worry about what our triangle looks like, whether it's negative or positives. All we have to know is theta is here, this is 8, this is 9, and we need to find that third side. We know we're in the first quadrant, so cosine will be positive. And then we're going to have to figure out, because we have these two, will theta over 2 be in the first quadrant? Yes, because something divided by 2 does not go negative, so it's not going to go into this quadrant. So if the degree is 1 degrees, let's do it in degrees. 1 degrees divided by 2 is half a degree. It's still in the first quadrant. If we were in the second quadrant, like let's say we were 100 degrees. Well, 100 divided by 2 is 50, and that would be in the first quadrant, so we'd have to be careful. But in this case, we're in the first quadrant. It's not going to turn negative, so all of those angles will remain in the first quadrant. All right, how do we find this? We know that 8 squared plus whatever that other side is equals 9 squared. X squared equals 9 squared is 81. 8 squared is 64. So x equals the square root. 81 minus 64 is 17. So this is the square root of 17. Because of the sine and cosine, double angle, and half angle formulas, we are going to need the sine and cosine of this angle. So sine of theta is already given. 8/9. And cosine theta equals square root of 17 over 9, adjacent over hypotenuse. Now, let me look at our formulas here. We're not asking for any tangents, and I don't think we need any tangents by our formulas. Yes, we don't need tangents, so who cares about tangent? All right, let's do a sine of 2 theta. Something is going haywire here. Wait a minute, I can't find my cursor. Okay, sine of 2 theta equals sine of 2 theta, 2 sine theta, cosine theta. 2 times sine of theta times square root of 17 over 9 equals 16 square root of 17 over 81. And let me just, I've already worked it somewhere, and yes, that is the answer. I just want to make sure that I'm not making any mistakes. Cosine of 2 thetas equals, what is the formula for cosine 2 theta? Well, we have a lot of different formulas we can use. Let's try 1 minus 2 sine squared theta. That seems, because we already have sine. 1 minus 2 sine squared theta equals 1 minus 2. Sine is 8/9. Sine squared is 64/81. 64 over 81. So that is going to be 81. I'm using a common denominator. 81 over 81 minus 128 over 81. And that equals 91, 101, 111, 121, negative 47 over 81 is the cosine of 2 theta. Well, that makes sense, because if theta is somewhere here, then 2 theta is probably over there somewhere in the second quadrant. Okay, let me double check it to make sure. Negative 47 81s. That is what it is. I was just thinking of something and it had me worried. And let me see if I can figure out what it is. Oh, didn't have me worried. I wanted to try one of the other formulas for cosine 2 theta. Cosine 2 theta is also cosine squared minus sine squared theta. So let's try that one. We get square root of 17/9 just to show you, if we had used this one, minus 64 over 81. Okay, and 17, square root of 17 squared is just 17 over 81 minus 64 over 81. And that's negative 47 over 81. So see, same answer, even if we use a different one of the cosine formulas. So just wanted to show that. Okay, I think I have enough room. Let me put these down here so I don't forget them. Sine of pi over 2 and cosine pi over 2. And again, I will remind you, any angle in the first quadrant, if I divide it by 2, it remains in the first quadrant. 88, let's say it's almost 90. 88 is in the first quadrant. Half of that is 44. 1 is in the first quadrant. Half of that is 0.5. So I'm going to remain in the first quadrant. I'm still in the first quadrant. If we had an angle in the second quadrant, or the third quadrant, or the fourth quadrants could change. But here, I'm here, where everything is positive. So when we use these half angle formulas, it goes by the sine of whatever it is, sine or cosine, in the first quadrant, or I'm sorry, in the quadrant where the half angle is. And in this case, the half angle is in the first quadrant. All right, sine of pi over 2, we have a formula, and it is, we're going to use positive square root 1 minus cosine, so this one is square root 1 minus cosine theta over 2. And I've already forgotten, so let me just double check. 1 minus cosine theta over 2 equals square root of 1 minus the square root of 17 over 9 over 2. Well, generally you don't want to have a square root in the denominator. I don't know if your answer will work like that. So I can take 2 out of there, which would be, there's all kinds of ways to do it. 1 over square root of 2 times the square root of 1 minus square root of 17 over 9. And 1 over square root of 2, if we multiply it by square root of 2 over square root of 2, gives us square root of 2 over 2 times the square root of 1 minus square root of 17 over 9. There's all kinds of different ways to write this answer. How your book has it, I don't know, or how the computer will accept it, I don't know. But there's one way to write it. There's others. If you look it up on the link I sent for the half angle and double angle, they give it in a different format. Okay, so there's that one. Now we have cosine theta over 2, which is 1 plus cosine theta over 2 square root. And again, it's positive because cosine is positive in the first quadrant. And we know this is in the first quadrant because if the angle is in the first quadrant, half of it is in the first quadrant. It's never going to switch. And again, if we were 100, which is in the second quadrant, half of that is 50. Then we could switch quadrants. But if it's already in the first quadrant, it's not going to switch. So we get 1 plus cosine theta equals square root of 1 plus square root of 17 over 9 all over 2. And that equals, we already found out that if we pull the 2 out, we get square root of 2 over 2 times the square root of 1 plus square root of 17 over 9. However you want to write it. And it doesn't matter. I mean, you can write it like this. Square root of 2 times the square root of 1 plus square root of 17 over 9 all over 2. Either way, it doesn't matter how you write it. However, I don't know how the computer takes it. But there, we found the cosine of pi over 2, sine of pi over 2, sine of 2 pi, cosine of 2 pi. That is 7-6, number 1.